Hello there. This video is on inferential statistics. We're going to review what you did in 504 and relate that to your projects. So this is a summary chart for various different inferential statistics approaches. Now I've posted this chart on the Blackboard site and I just want to go over it quickly with you. The idea here is that if we want to reject the null hypothesis, i.e. that there are no differences between the samples or maybe the data that we're looking at, we ask, is the obtained value beyond the critical value? Or put another way, does it fall within the critical region? And as you can see in this chart, we can do that for one sample, i.e. the sample versus the population. And we have different formulae depending on whether it's a large sample size or a small sample size, and whether you're using a mean as the key measure or proportions as the key measure. Now there are different formulae if we're comparing two samples. And again, we might have a large sample or a small sample, and again, be using different measures within those. Now the third and fourth approaches we might use are ANOVA, which is 3 or more samples. And for that, we'd be interested in doing an F-test and a chi-squared test, which is when we have bivariate data. This is a stepping stone because we start to look in multiple dimensions. So for a chi-squared, we're thinking about comparing our observed F value with our expected F value. So as you can see on this chart, there are lots of little red letters. So A's and B's and C's. You can use these letters in the document to connect through to the second and third pages, and that gives you more information about each of these different tests. So how do inferential statistics relate to our 506 projects, I hear you ask? Well, the relation is that the core idea is somewhat the same. So we are testing whether each independent variable is correlated with the dependent variable with respect to particular thresholds. Now, these thresholds are similar to those critical values that we're thinking about for general inferential statistics. If these thresholds are met, we deem the variables and their coefficients to be statistically significant. Now, this is akin to the obtained value falling into the critical region or beyond the critical value. Usually, though not always, so make sure you check the specifics in the key, one asterisk in a regression analysis table would refer to p is less than 0.1, which in other words, the coefficient is significant at the 90% level. 2 asterisks suggest that the coefficient is significant at the 95% level, and 3 asterisks usually implies that the coefficient is significant at the 99% level. So as we saw in the first video, in our regression results table, these asterisks are really important. They tell us how significant each coefficient is. And based on the statistical significance of each coefficient, we can start to interpret the results and say whether the relationship, positive or negative, matches what we expected, and then whether the size or magnitude of that relationship can tell us something more detailed about that relationship. I hope this has been a helpful video, and please let me know if you have any questions on it.